Hi guys, welcome back to my fourth session. So this session will be based on IP addressing, IPv4 addressing, why we need IP addressing and subnetting of the addresses. Okay, so let us proceed to our session. Okay, so IP addressing. So what is an IP? So the abbreviation is Internet Protocol. As we know, it's an protocol. And why it is used? You have your home address, right? Like you have Washington DC, and you have some addresses, numbers, and something. So same way in a network, if some PCs should be identified, some address is required, which is IP address. So in this diagram, you can see that there are four PCs. So if first PC wants to send the data to third PC, then it should have some source address and destination address, which is the IP address. It's like your home address. So each PC within a network will have some unique addresses. So what is the advantage? It will be easy to identify the PC. So in the network, it's a 32-bit address. Each is 8-bit, 8-bit dot 8-bit dot 8-bit dot 8-bit each. So it becomes 32-bit totally. It's a 32-bit address, and moreover, using these addresses. Okay, so IP addressing. So example 10.0.0.1, 10.0.0.4, and it's 192.148.254.4. So the first octet in is the first number. For example, 192 is the first octet. Octet is that 8 bit. First 8 bit is 192. Second 8 bit is 148. So this is the format x dot y dot x dot y, like x dot x dot x dot x. So it's like that. It ranges from 0 to 255 as it is an octet. And so, what are the rules of grouping IP addresses for a network? So, I can group, for example, 10.1.x.x. So, my network part will be 10.1, which is constant, and that x.x will be your host part. That is, it is changeable. So, for your first host, you can keep 10.1.2.2, or for your second host, you can keep 10.1.3.2. So, first two 8 bits, 10.1, which is the network part, and the x.x, which is the host part. So, it can differ. So these groupings are done because in order to separate the networks. So 10.3.1.1, if 10.4.x.x, if you group the IP address, then this won't be, it won't come under the same network. 10.3.1.1 will not come under the same network. So this is one of the major concept you must understand. So the network part and the host part in an IP address. If you understand this, you can proceed very easily for subnetting and finding number of devices, etc. and etc. Okay, so we have different classes of networks, different classes of IP addresses you have, which is class A, and you have class B, and you have class C. Class D and class E are used for other purposes, not for common use. And class D is mainly used for multicasting. It is like 224 or some addresses which will be learned further. And class E is used for research purposes. Research purposes for IP addresses or any other research purposes, class E is used. So what is class A? Class A is nothing but the first octet is alone fixed. So the first octet is alone the network part. So 10.x.y.z is an example of class A address. So if 10.0.0.1 is used, another address may be 10.1.0.2. So the first part 10 alone should be the same, which is the network part, and other three parts are host part. So total 24 host parts are there. So it supports almost 2 power 24 addresses. Okay. So, as I already said, the last 3 bits alone changes. That is, in the sense, that is the last 3 positions, and it supports 116 million. I think it is almost 1677214 addresses exactly. It supports class A. So these many addresses are supported in class A alone. So what is class B? Class B is nothing but first 2 positions are fixed. X dot y is the host part here. So 10.1.2.2, 10.1.3.3 can be within the same network. But if you try to insert 10.2.2.2, it won't come under the same network because the address should start with 10.1. So the first 2 positions should be same. It supports almost 2 power 16, this 65536 addresses totally. So what is class C? So class C address is nothing but the last bit is alone the host part, which is the last 8 bit alone is the host part. First 3 bits are fixed. So it supports 2 power 8, which is 254, 256 and 254 addresses. It's like so. Other it support 2 power 8 is 256. Two addresses will be used for some special purposes. So the total address supported is 254. So you can see the network part and host part in the diagram. Okay, so range of addresses for all classes. So you just have a look at it. So for class A it is 1.0.0.0 to 126.0.0, and for class and 127.0.0 is for loop back testing. For example, you have a NIC card, so whether the NIC card is working or not, whether it is in the network or not. So for that you can just ping 127.0.0.2 or 1. If the card is working, then you will be getting a reply from that. So it's for testing purposes, and class B is 128.0.0 to 191, and class C is 192 to 233 to 255 to 255. So we represent class A as 255.0.0. The first octet is alone fixed. So the subnet mask. So even in your computers, when you enter IP addresses, you would have seen two fields. First will be IP address and second will be subnet mask. So using the subnet mask only, we can determine which class the address comes, like which parts are fixed. 255 in the sense only first octet is fixed. Others are network parts. Others are host parts. Sorry. So this way. So and class A addresses are commonly referred to as /8. 8 bit network part. First part alone is network part. So for example, if 10.0.0.3/8, then it is commonly referred to as class A. So this is one of the important concepts. So in IP addresses, maximum it will be represented as /8/16 for class B, which is 255.255.0.0, and /24 is for class C, first 3 bits. So 8 into 3, 24 bits. So it represents that only. So 8 plus 8 plus 8, 255, 255, 255, which comes to 24. So it is like that. It's one of the important concepts for subnetting. It will be useful. So what is IP subnetting? So subnetting refers to subdividing the IP addresses into groups. So it will be learned later in this slide. You will be knowing how to subnet each of the things. So what is the use of the subnetting? You can save many IP addresses by grouping and subdividing into the IP addresses. For example, you have 5 PCs. You use class B address, which supports 65534 addresses. So almost many of the addresses are wasted. So to avoid this wastage of addresses, we use the concept called IP subnetting. That is subdividing the class B to other networks. That is to provide efficient IP addressing scheme. Okay. So how do we determine the subnet? So number of hosts required in one network. So how many number of hosts are required in one network? According to the size of network, we choose the IP groups. For example, if you have 5 PCs, then the subnet will be different. So it's like that. So the number of hosts, so how many number of hosts in a subnet can be calculated by the formula 2 power h minus 2. For example, if it is 24/24, then there are 8 host parts. So it is 2 power 8 minus 2. 2 power 8 is 128 and it minus 2 is 126. So this is going to be the formula 2 power h minus 2. This is one of the important formulas in your exam. Maximum IP addressing questions will be based on this only. So 24 is your host part. So 32 minus 24 will give you the host part. 24 is your network part. Sorry. So 32 minus 24 will give you the host part. There are 32 parts totally. So last host part alone will become the h. So 2 power h minus 2. So n is the bits of host part, and for class B it is 2 power 16 minus 2. Okay, so what is VLSM? VLSM is nothing but variable size subnet mask. Variable length subnet mask, sorry, not variable size, it is variable length subnet masks. So for example, you have a network with 50 devices, then effective way of choosing the subnets is 2 power 6 minus 2, which is the host part is just 6. So using 6 host parts, you can just do this. You can just accomplish this job. So how to do this? So variable length subnet mask give allows us to do this. So if there are 120 devices, for example, you just consider 120 devices. So for 120 devices, last 25, that is 7 host bits is enough. 7 host parts are enough. 7 host bits are enough. So 2 power 7 minus 2, which is gonna give you almost 120. Wait. So what is a public IP address? Public IP address in the sense, so the companies have to register their IP addresses, right? So the company should tell the number of devices. First of all, before it was like if there are 1,000 devices, then the companies must give. For example, consider a company ABC company. It has 1,000 devices. So it must tell the ISP that I have these many devices, and each device will get its own IP addressing scheme. So IP address. So by 1990, the IP address started to exhaust. So the IP addresses were short, fall short. So giving class ABC was not good. So some change was expected in IP addressing scheme. So NAT came into the place. So NAT came to avoid this problem. So NAT is nothing but network address translation. For example, if two companies have same network address also, using NAT it can be translated. So consider a company have 1,000 devices, but with 10 public addresses, all the 1,000 devices can be used. So this is the main advantage of NAT. So for NAT, you have a separate chapter and you have a separate video where you will be learning lot of concepts in NAT. You have inside global, inside local, and there are a lot of concepts. But for now, you just have an idea like NAT is just to translate the IP addresses. So you can have some private addresses, only 10 or 15 public addresses. So within that pool of addresses, you will be able to translate the whole system. So just have a look at this slide. This is one of the important concept. So public IP addressing. Okay. So what is private IP networks? So private IP networks are nothing but these addresses cannot be given to any public networks. So there are some fixed ranges only for private. So if the company is going to use NAT to translate their addresses, it can use private. Or if the company do not want to publish their addresses or do not want any public addresses, no connection to internet, then they can use their private addresses. So only for private use. So these are the ranges. So all 10.0, for example, 10.1.2.2, 10.1.1.1, 10.0.0.5, everything comes under private addresses. And 172.16.2.2, 172.16.3.3, and so these ranges comes under private addresses. And 192.62.0.0 comes under. Okay, so class full network. Class full network are nothing but class A, B, C networks. For example, class A. So before we subdivided the network, we had only class full networks A and B and C. So in class A, the first part is allowed network part, and H.H.H others changes. And in the class B, first two, as I already said, and in class B, first three is going to be network part. Okay, so we have class ABC only, which was not at all efficient because there was shortage of addresses, and you must also subdivide the groups further, subdivide class B or subdivide class C in order to get efficient addresses. Now calculating the number of devices in class A, class B and class C. So already I told. So do you remember the formula like 2 bar h minus 2? H represents the host part. For example, so n dot h dot h dot h, which is gonna be your class A, last 3-bit changes. So this h, so each is h is 8-bit. So 3h will contribute 24 host bits. Okay. So 2 power 24 minus 2 will give you almost 16777,214, which I already stated in one of the previous slides. So this is one of the important. You must just memorize these things because in your question you may get in CCNA they'll be asking what are the devices supported, how many number of devices are supported. Okay, so here it is 2 power 16 minus 2, and for class C it is almost only one host bit, so it is 2 power 8 minus 2, which is gonna be your 254. So only 254 addresses are used. So if you want 200 devices, then you can go for class C. If you want more than 254 devices, you can go to class B. If you want more than 65534 devices, you can go to class A. So it was like that. Okay, so have a look at it. Okay, so subnet mask. So suppose consider class B, which so n dot x dot y is class B, right? So the network part is represented as 255 or 255 So if you just go to your computer like network properties and network adapter settings, you will be having two fields, IP address field and subnet mask field. The subnet mask field, if you enter 255 or 255.0.0, then only it will recognize it as class B, because the first two octets are fixed, so it is represented as 255 or 255. And class A first 8 bits alone for network part, so 255.0.0. And for class C it is first 3 positions are represented, so it is 255 or 255 or 255.0. So each octet is filled, so it's not gonna change. So it will be, so see the diagram, so it will be having IP field and a subnet mask field to determine. So just have a look at this slide. Okay, so 255 or 255 or 255.0. So in this mask we will use 255 bits, that's why we waste lot of addresses. So we can't use anything apart from 255. There was no chance, like if you can use 254 or 252 or 242 or 248 or any other addresses, so you can just subdivide these subnets, these classes into subdivisions, subnetworks. So in next slide there will be a conversion table which you should be familiar with. So you just take a note and note the values from the next slide. So the slides, so that you can follow the rest of the session. It will be very easy for you. So binary, decimal and number of binary ones. So you have 0, 128, 192. You must be very thorough with the table. If you go to your CCNA exam, first try to write this table, represent the table in your, so they will be giving you a scratch pad, right? So in that you just write the table, which will be easier for you, because you will be having a lot of IPRSS questions in your exam. Nowadays there are a lot of IPRSS questions. Many students will fail to attend IPRSS questions which are very easy. Now I am going to show all the questions, what are the format of questions which will appear in your exam. So just take a note of these things. Just have a paper and just note this down, and take a note before we proceed to the next slides, because you need a note for working out your calculations. Don't use calculator for practicing, because in your exam you will not get any calculator or Windows calculator. Okay, now let us do some practice with these subnets. If the question is what is the subnet mask for 192.168.0.1/27, then what you will do? So it is gonna be 27. So 8 plus 8 plus 8 plus something. So 8 plus 8 plus 8 is 24, and 24 plus 3 will give you 27. So it is 255 or 255 or 255 or 224. Why I use 224 is from the conversion table you can see that 3 represents 224. So this 3 will represent 224. So you just have a look at the conversion table. So which will provide, see, 224 it is 3, right? So this is the way from which we identify like what is the mask used. So if you use this, so instead of this 255, you subdivide the 255 itself into some of the subnets. So this is one of the key concept you must be knowing. Important questions. So in CCNA you will be getting some questions based on this. For example, tender, what is the mask for /26? What is the mask for /18? What is the mask for /29? You must be thorough with the table values, so you can proceed. Okay, so now it's time to test your knowledge. So what is the subnet mask for /26? So try to provide the subnet mask for /26. So there's a clue. 8.8 plus 8 plus 8, which is gonna be 24, and it should be plus 2, right? it is going to be 8 plus 8 plus 8 plus 2, which is going to give you your 26. So each 8 is going to represent 255. So it is 255 or 255 or 255 plus 2. So what is 2? You must go and see in the table. So just have a look at the table and just have a look at the answer. If you have done this correctly, you have understood this concept, understood this calculation. So it's gonna be 192, right? You can just check with the table. See, it's gonna be 2. So 2 represents 192, right? So that's why we have chosen 255 or 255 or 255 or 292. Sorry, 192. Okay. So now you just try for slash 31. So for slash 31, what's gonna be there? What's gonna be the answer? So this also, it is also 8 plus 8 plus 8 plus 8. Sorry, 8 plus 8 plus 8, which is gonna be 24, and plus 7. It's gonna be 7, not 8. See, so 8 plus 8 plus 8 plus 8 plus 7. So for 7 you can just check. So it is 255 or 255 or 255 dot, what's the value for 7? We just look at the conversion table. So it's gonna be 254. See, you can just have a look at the table. It's 254. So you must be thorough with the things like slash 24, slash 25, it's 128, 192, 224, 240, 248, and you must be thorough with the concept. So now let us consider an example slash 28. Okay, so how many addresses, like how many hosts are supported? So in this host part, how to identify the host part is subtracting 32 minus 28, which is gonna give you host part. So here 8 plus 8 plus 8 plus 4, 4 represents 240. So this is the concept. So 32 minus your slash what x, that is slash, if that is slash 27, 32 minus 27, because 27 is your network part, remaining are host part. So that's why you subtract. Now finding the number of devices supported. So as I already told, we found h by subtracting 32 minus your x value. That is in slash 29, it is 32 minus 29, which is gonna be your 3. Okay, so now apply the formula 2 power h minus 2. So it's gonna be 2 power 3 minus 2, which is gonna give you 8 minus 2. So 6 PCs are supported, only 6 PCs. So you just see in class C it supports 254. Then in this subdivision it supports 6. So if you wanna use only 5 PCs, you can go for this easily. If you wanna use 6 or 4 or 5 PCs, you can go for this. It's efficient. Now it's time to test your knowledge. So I have a company, I have 100 computers. I want to choose a classless network. So what we saw, class A, class B, class C, they are classful. Here it is classless. Which mask can I choose? So the address I want to buy is 192. So it can be of any range. So take a note and work out. So which mask I want to buy? So you must try for each thing, for slash 30, for slash 28, and you just see, so which IP best fits my requirement. What's the efficient network I want? Okay guys, so now let us check the answer. So now I'm gonna try with slash 28, which is 32 minus 28, which will give you 4. So it supports only 14 PCs. Then I'm gonna try with slash 26, which is giving you only 62 PCs, 2 power h minus 2, 2 power 6 minus 2. And now I'm gonna try with slash 25, so it is 7. So 2 power 7 minus 2, which is gonna fit me. So if you go to slash 24, which is gonna give you 256 addresses. So slash 25 is efficient. If you use slash 24 also, you can do that, but it's more efficient. You can save many IP addresses. So this is the main concept of subnetting. So the mask will be 1.128, because you have from the table value you can just get it easily, right? So for 25 it is 8 plus 8 plus 8 plus 1, so for 1 it is 128. Okay, so how to find range of usable addresses within the network? So for slash 29, so for example take the for example take the mask slash 29. So steps to find the range of addresses. Slash 30, for 30 it is 255.255.255.252. Okay, so now what you do is you just subtract 256 with the value given, so which is 252, and it gives you 4, right? So what you do is make 4 tables in one side, which is 0, 4, 8, 16. So as I already stated, so 0, 4. So 4 minus 1 is 3. So write that directly opposite to the 0. So 8 minus 1 is 7. Write it directly opposite to 4. 16 minus 1 is 15. Write it directly. So now the range of usable addresses. So for example, if I used 192.168, so 192.168 at 0.2, 192.168 at 0.3, 192.168 at 0.1 slash 30 will be different network, and 192.168 at 0.8 and 192.168 till 15 it will be another network. So there will be two networks. So you subdivide each class itself into two networks. If you try to ping from one network to another network, then you cannot ping. Okay, so the ranges for slash 30 are shown. In your exam, the question may be asked as follows also. Like you'll be having different questions, but it is based on the concept only. So consider this question. Which of the following is the last valid IP address for slash 27? So whether it is 63 or 62 or 61 or 60. Okay. So now let us have some calculations. So this is one of the major type of the questions asked in a CCNA exam. So this will be asked, and so for slash 27 we know it is 224 because it is 8 plus 8 plus 8 plus 3, which is gonna be 224. So 32, and you prepare the 32 table. So 0, 32. So before 32 is 31. So you choose 31 and you put 63 there because 32 is 64. So from the options given, 63 cannot be the option because the ranges must be between 32 and 63. 63 and 32 cannot be used. So it must be between. So 32 is the network address. It should be between 32 and 63. The valid addresses are 61 and 62. But they ask last usable IP address. So 61 is also correct, but from the question you can identify that it's last used IP address. So it is 62. Okay, now let's move on to next question. So given an IP address 192.168.248. So what is the subnet address? Okay, so see this question. So what is the subnet address? They have given some address like 1.42, and they have also given the subnet mask. So for 248 it is slash 29. So remembering these values comes by practice only. Practice, practice, practice. First as 30 it is 252, 254. As I already told, you must practice a lot for this IP address thing. So the answers must be C or E only. So from the question directly they have given. So now prepare the table. 256 minus 248 equal to 8. So 0, 8, 16, 24, 32, 40, 48. Here it is 7, 15, that is 16 minus 1, 24 minus 1, 32 minus 1, 40 minus 1, 48 minus 1. So dot 16 is invalid because the range is between 16 and 23. It's not a valid address. So address given in the question is dot 42, right? So dot 42 falls under 40 and 47. 42 is falling under 40 and 47. So the network address must be 192.168 1.40, right? So we choose C as the correct answer. See, you have that answer. So here we first of all eliminated A, B and D because from the question it is 248, but see here they have given slash 27 and slash 28. So we have eliminated. So you must be knowing that also. Okay, now it's a chance for you to try this question. So what's the network address for the host with IP address 192.168.23.61/28? So you just work out in your note and we'll be checking the answer in our next slide. If you want to take more time, you can just pause this video and you can just work out. And guys, be sure with these type of questions, because in CCNA exam you're really gonna face these type of questions only. Okay, so slash 28 already I told you, which is gonna be 240. So 256 minus 240 is gonna be your 16. So prepare 16 table, 16 minus 1, 13 minus 1. So you have prepared. So the question has the address 23.60 thing. So with it falls 48 and 63. So the network address must be 48. So the answer must be C, right? So this is one of the simplest question. Okay, so many of them know about this term ping. Ping is nothing but it's used to test the connectivity between the devices. It is packet internet grouper. Okay, okay. So guys, thank you for reading this session. So if you have any clarifications, you can just contact me at www.facebook.com/youngestccnp, and I have a Twitter account, which is avinash1998. You can contact me through that also.